Hello and welcome to another Jog Vlog session. This one is going to be looking at physical and human causes of coastal erosion and retreat. So whilst we have actually looked at some of the physical factors that affect coastlines and actually some of the human processes involved too, we're actually going to affect everything else that can affect the coastline. So anything else we haven't yet covered, which isn't necessarily something we connect to the formation of coastal landforms, for example. So we teach you that first chunk of erosion, weathering, mass movement, deposition, because those are things that are important when it comes to the creation of those landforms. But it's also important that you know the other factors that can cause coasts to erode and to retreat backwards. And so within this, we're going to be looking at the physical factors that we haven't covered yet, so weather and climate, and how they affect coastal retreat and erosion. But we're also going to look at human activities and again how they impact, whether we protect the coast or how vulnerable the coast is to erosion and retreat. So write today's title down and then I'll kick you off with some fascinating facts. So 5 facts for you. 28% of the English and Welsh coastline is eroding at more than 10 centimetres a year. And 1,800 kilometres of the coast is at risk from erosion and retreat. But yet only 340 kilometres of that 1,800 kilometres is defended with sea defences. It doesn't mean it's not managed, and we'll get onto that in another session, but it is only 340 is actively defended by groins, seawalls, riprap. There are about 200 homes at risk of falling into the sea now, approximately, but within a decade that will be tenfold increase, to 2,000 or so. So this is a very relevant and contemporary issue, and it's not something which we can explain away with just traditional erosion. And one of the bigger factors that's leading to this increased retreat and this risk of homes is actually coastal flooding as well as sea level rise. So combine erosion and all those other factors with coastal flooding and sea level rise, you're going to get all these orange areas, and they're the ones you want to focus on. Ignore the black number for now. These orange areas are at risk of coastal erosion and retreat, hugely at risk. Okay, and you can see around the east coast of East Anglia, the Wash, Holderness, which we cover as well. Huge areas of the English and Welsh coastline is really at risk of erosion. And I've got some examples for you as well. Haysborough and Norfolk and Sidestrand, both in Norfolk, close to home. The mean retreat over the last 10 years, and we've seen a huge increase in Haysborough, 90 metres. Okay, 9 metres a year. That's an absolutely incredible rate of erosion in one area. Now that slows down to a certain extent, but there's also areas in Haysborough. Sorry, Haysborough was managed previously, and they've stopped managing it now, effectively, or they haven't stopped managing it, but they're doing something called managed realignment, which is basically stopping managing it. And so the coastal defences are actually failing there, which is leading to this huge retreat. There's landslides as well, and again, you look at the sort of cliff material that you're faced with in the East Coast, it's very soft geology and it's prone to slumping. And if you add weight on it, like a holiday park, then that slumping is going to continue. Look, there's a big chunk here, which since this picture's been taken, that's gone. Okay, that has gone big time. So it's not hard to imagine that once this lot goes, that's in one chunk. You're looking at 5 metres in one go there, and that over one night of bad weather, that can all go. And again, Aldborough, which is Holderness and Yorkshire, again, you get landslides, you get storm damage, etc. So there are other factors at play, not just the kind of traditional hydraulic action and abrasion which create those cliffs that we've seen. Now, this essentially is just where you write some notes. So I'm going to leave the notes on the board, or not the board, on the screen. You can pause it once you need to pause to get all the notes done. But I will talk you through the notes once, and then you can stop and pause it and get them. So we know that geology is a factor, and how hard or soft the geology is a big physical factor that affects the rate of coastal recession, and it's probably the biggest factor, the most large scale factor that we consider. But the weather and climate is also something we need to consider too. And one particular event, which you can see pictured here, storm surge events. The 1953 storm surge was particularly damaging for a number of reasons. And I'll explain those in a bit. So storm surges happen every now and then. 1953 is the most well known purely because it was the most damaging in terms of human life, in terms of land lost. And so storm surges, which is as a result of the sea level rising, for a few factors. One, it's a low pressure system. So weather people, meteorologists, talk about low pressure all the time, or high pressure. Low pressure, all it means is air is rising away from the surface of the Earth. Now, air has mass, and you can feel it. If you wave your hand around fast enough, you can feel the air brushing against your hand. So air does have mass, not a lot of it, but when you think of, like, above your head there's over 17 kilometers of air. That's quite a lot of air, which can create quite a lot of mass. So when air is sinking, it creates high pressure, and that's great. High pressure is lovely because you get settled conditions, cloudless skies, because the air is all moving down, and as it moves down it gets warmer, and it doesn't condense and form those clouds, and it's nice and settled. And in fact, it stops any air being able to move in to fill the space, because the space is never really being created. As the air sinks, it just squishes more and more air downwards. And some people get headaches during high pressure events, and again, it's cited because maybe there's increased pressure on them. And high pressure is called high pressure because it literally exerts force onto the Earth. Now, when high pressure systems go onto the sea, they actually depress the sea, and they push it down by a certain amount. And the opposite is true when you get low pressure. So at low pressure, air rises, air goes upwards, and that means the pressure on the sea is released, and that can actually increase the level of the sea temporarily quite a lot. In some cases, sea level rose over about 3 meters on average around the UK because of this low pressure system. Now, the other thing that low pressure does is it creates space. If you imagine all the air is moving away up, the only place that's going to fill in, and it doesn't create a vacuum, because otherwise we'd all suffocate and die. So when that air moves up, air all around that area moves in to fill the space. Now, if that air is rising quickly, air quickly moves in to fill the space, and we feel that moving air as wind. That's how wind is created. The sun creates wind because it creates that movement of air. So as air moves up in low pressure systems, more air moves in, which creates wind. And we know that wind, and strong winds particularly, create bigger waves. So not only is the sea high because it's being less pressured by the air above it, it's also creating bigger waves because there's now strong winds dragging across the surface. And when you combine that with a high tide, and even worse than that, you combine it with a high tide going down into the North Sea, which creates a funnel shape here at the bottom, then all the water builds up. So low pressure plus high winds plus high tide plus funnel effect, it creates bad news. And that storm surge in 1953 killed 307 people in East Anglia and Lincolnshire and Kent, but also hundreds of people in the Netherlands as well. And they were literally finding bodies in trees that had just been overwhelmed by floodwaters. Incredible. And horrendously tragic, and it really affected us on the East Coast as well. There's a chap that lost all of his family in Sea Pauling after just coming home on the bus from the city. It's just madness. And 1953 being a time when there wasn't Twitter and there wasn't Environment Agency warnings and all that sort of stuff, and meteorologists, Met Office warnings, was actually probably the reason it was more devastated. But also, we weren't prepared for it. The housing near the coast wasn't very structurally sound. It was prefabricated housing. It was single story, and the defences we put in place for storm surge events were woeful. And we've actually had a bigger storm surge in 2013. So 60 years later, another storm surge, which was actually bigger, affected North Norfolk. So high it was knocking up parts of the Cromer Pier, the footings, the boards that you walk on. And imagine going on there, how far above the sea you are. The sea has to be very, very high if it's going to knock those boards up. And it destroyed bits of seawall. But the casualties, in terms of human casualties, were very low. And that's because we were better prepared for it. So the North Sea storm surge, so storm surges is one way that coastal erosion can be increased massively, because higher seas, bigger waves, going to reach further inland, can create lots of erosion. And just Google pictures of Cromer after the 2013 storm surge, and you'll see big chunks of concrete wall just decimated. because the sea came in so high. And rising sea levels is happening anyway. And so along the English Channel, but everywhere really that's getting warmer, the seas have risen. So 12 centimetres in the English Channel, which is huge in the last 100 years. Doesn't feel again like a lot, but it's speeding up. They're predicted to rise by another 11 to 16 centimetres by 2030, which is 10 years' time. Now, the other thing, and most sea level rises, isn't actually necessarily from more water. You might think it is, and land ice is melting and contributing to sea level rise, but it's actually much more because of the seawater is thermally expanding. So ever wondered why it's hard to get your rings off when it's a hot day? It's because your hand is expanding. Now water does the same. When it's hot, water thermally expands, and more sea level rises due to thermal expansion of water than anything else. So as global warming continues in certain parts of the world, and obviously the climate change that's going to enact, it's also going to create thermal expansion of water, which again means that the waves, sorry about that, the waves can reach much further inland and therefore cause greater erosion and therefore greater retreat. Okay, right, so pause the screen, get all those notes down, and again, if you want to find out more about the North Sea storm surge of 1953, I've got a very sad documentary, but it's a very good documentary that you can watch. If you just come and ask me for it, I'll sort you out. Okay, when you're ready, unpause the screen, and we've got some more notes to come, I'm afraid. So we've looked at the physical factors that can cause erosion and retreat, and you could even add into that the fact that in winter you're more likely to get stormy conditions, so seasonality, which is a weather and climate factor. There's more erosion in winter than any other time of year, particularly in East Anglia, is also true. God, we're getting it all today. So human activities that disrupt the natural process and balance of coasts. So again, another reason why more erosion might take place, because we're building groins, and we love groins. You can see groins up here, and we're going to do a whole lesson, or not a whole lesson, but part of a lesson on groins as well going forward. But we build groins, and groins trap sediment, but that's great for that bit of coast. But the bit of coast downdrift is expecting that sediment naturally to come to it, and we've stopped it. So we starve the beach further down, and as a result of that, it increases erosion. So where we've got groins, it's good for this particular part of the coast because it builds up a beach that creates lots of friction, nice for tourists. But further downdrift, you starve the beach, and therefore you increase erosion down there. So that's how humans can definitely affect erosion along the coastline, because we interrupt this process. Another way is that we dredge, and again we dredge for a number of reasons: for aggregates, for building, but also to pump sand back onto the beach when it gets a bit thin, and that dredging can essentially create deeper areas. Now, one of the best coastal defences we've got is the fact that beaches exist, or the sea gets shallower the nearer to the coast it gets. But if we dredge it, we remove that friction with the waves. So the waves, when they reach the coast, have more power because they haven't actually gone up a gradually shallowing slope. So if you make it deeper, the waves retain that energy, and so they've got more power to attack the cliffs with, and that can lead to greater erosion. And this was absolutely felt, and this is a great example of this. They actually dredged a huge area to build the Plymouth docks, which to allow big kind of huge hull bottom boats, big boats, container ships, that sort of thing. And they actually did it so before containerisation, in 1897. But in 1897 they dredged 600,000 tons of gravel from the seabed, and it made it so much shallower that the wave energy was less disrupted, and a place called Hall Sands, not related to me, was actually destroyed by 1917. So 20 years passed, and an entire village was gone because of this dredging that went on at Plymouth docks. And again, if you Google it, you can read up about that. And then we can also have the opposite effect. If we protect anything, then we effectively are stopping erosion. So not only, we don't necessarily always increase erosion and retreat, we can actually stop it altogether. So if we build things like sea walls, they're pretty good at defending us, and you put in front of it riprap rock armor, that's pretty good. So the area behind that is going to not erode at all, and that's not something we would expect to happen normally. So there you go. Again, more notes for you to write down. Pause the screen and get those down, please. Okay, and something else we've got to consider as well is just this need to protect. So lots of people live near the coast, and I gave you some stats at the start of this session about how many homes are at risk of falling in the sea and how many will be in future. And we do need to protect and manage the coast, and this is going to be something which leads into my next session. Okay, with the next lesson on YouTube. Urbanisation is one factor. People live near the coast. You think of Great Yarmouth, although you might be a bit snippy about Great Yarmouth and it's fallen into disrepair, etc. There are loads of towns on the east coast which are very close to the sea where thousands of people live. And relocating thousands of people is not an easy task. So not only do we need to protect these areas, we also need to consider that they are adding pressure onto those cliff areas too. But the key is protecting them, and that's going to, again, reduce the erosion that we expect of that area. Now, this map shows you, this is a place called Mappleton, where they've built a rock groin here, and there's a nice big wide beach. This green area here is beach, and that's there to protect this land behind this farmland and some housing. But where the town sort of stops, so does the sea defences. And so south of this, and what you can't see is that what happens to the coastline, which is over here, then you've got the sea defence, then all of a sudden it goes down there. And because there's only very limited farmland there, not many houses. So because of urbanisation and the fact that we're moving to, more of us are moving to towns and cities, we need to protect those people's homes. We also need to protect areas of farmland because we want to try and grow as much as possible. In East Anglia, one of our most fertile regions in the entire country, is a place that is suffering with coastal erosion. And if we run out of our nice fertile farmland, then we're going to run out of the ability to be self-sustaining as a country. And we're not self-sustaining anyway, but we'll become even less sustainable as a country if we don't protect that farmland. Industry is huge as well. Again, although it's changing, a lot of our fossil fuels are gas that we get from our own oil fields in the North Sea, and gas fields, in the North Sea. And those are processed out to sea, and then via pipelines and things, they get transferred to places like Bacton or Easington. Both of those are two places on the east coast, one of them in Norfolk, one of them in Lincolnshire. And Bacton and Easington are both huge gas terminals that supply power to hundreds of thousands of homes. So it's really, really important that we protect those terminals. But also, docks and ports. Felixstowe is a globally important port. And it gets containers from all over the world, mainly China, but from all over the world that ship in goods that we rely on heavily in this country. So you have to protect those areas because they provide jobs, they provide products, and they are vital to our economy. And then lastly, tourism. If all the sea is eroding and the beaches are eroding and they're all narrow, then people can't be beside the seaside. And it's not just about the people that visit the seaside and the ice cream shops, it's about everyone else that gets a bit of a boost from those visits. So the hotels, the cafes, the pubs, and all the jobs that are associated with that tourism sector are hugely important. So again, we need management to protect those very, very key tourist areas and all the benefits they bring. So pause the screen, again, get all these notes down, and then you will have basically done this session, which I know has been very note-takey and a lot of me talking. But we need to be aware of these other factors that can affect the coast and why we need to protect it. And now, finishing on this slide, the need to protect is really important because it's going to lead on to the next session that we've got with regards to this topic, which is coastal defences. So we're going to be looking at physical coastal defences, but also we're going to be looking at management strategies because some parts of the coast are not defended, but they are all managed. So by managing some areas through not defending them, it means you've got more money to defend the important areas where people live, where there's agricultural land that's important, where there's industry, or where they are huge tourist attractions. Okay, thank you for listening. Again, I know it's a talky one, but well done. Get the notes down in full. Make sure if you want to go and revisit anything, and again, if you want to hear more about the 1953 storm surge, then please feel free to get in touch with me, and I'll point you in the right direction of a great documentary. But otherwise, look out for the next lesson on coastal defences. I'll see you next time.